Okay, so this is a PowerPoint presentation for my final exam of everything I learned in this course over the semester. So first, I'm going to talk about variables. Variables are data types. It's a place where the data is stored. There are different types of variables that you can choose based on what type of data you are trying to store. The primary variable types, known as data types, include integer, character, boolean, floating point, and double floating point. All variables must be declared as well as initialized. So first I'm going to talk about the integer variables. Integer variables are used to store only whole numbers. An int variable cannot be used to store decimals. You can use an integer variable to count something that cannot be cut in half like cars. So as you can see in the bottom, I created a program using int. I named it age. I initialized it at 0. And then I have the user give me their age. And then using cout, I display the age to the, to the console. And where on the right side where it shows that the program is being run, I entered 22, my age, and then did cout UR, and then age 22, and then years old. So that's an int. See, there's no decimal point. It's just an integer number, a whole number. A character variable can be used to store a non-numerical value. The two main character type variables are char and string. Char can be used to store a single letter, and string can be used to store a whole line. So right here you can see I created a char, a program with char, first and second, and I asked the user what are your initials. So then when I see in the user's input first initial and the second initial, and then I cout, I put your initials are, and then I use the cout to put first initial and second initial. And on the right side where you see I ran the program, I put my initials A and C. So the cout gave me those two initials. And those are char variables. If it was a string, I would have been able to hold more characters within each variable. A Boolean variable can only store a value as either true, which is equal to 1, or false, which is equal to 2. And you can see right here, bool yes, I named it yes, equals true, and then bool, which I named no, equals false. So when I cout yes, it gives me a 1, and when I cout no, it gives me a 0. Floating point variables are used to store real numbers, which are numbers that include decimal points. Using a floating point variable instead of an integer variable will give you a more precise value. And a floating point can either be float or double. Right here I use double sum and double average are my variables. And I use these so I can work with decimal points. Okay, so I asked the user to give me two numbers, and then I found the average of them. So on the right side you can see I ran the program. I entered 13 and 10, and then the average of the two numbers is 11.5. If I had used int variables instead of double variable, it would have just gave me a whole number. It would have been probably 11, which I would have lost data. So it's very important when you want to work with decimals or real numbers that you make it a floating point variable such as double. Next I'll be talking about assignment operators. A simple assignment operator. Assignment operators are used to modify the value of an object. The assignment operator is a symbol that is commonly referred to as the equal sign in mathematics. However, in C++ programming, two of these symbols means equals and one means assign. So right here I have an image of I assigned age to 22. If I had put two equal signs, that would have been equals. That means the actual value. but since I put one equal sign, that means it's not what is not the actual value of it. I'm just giving it that value. Namespaces. Namespace STD. That's a very common one. Namespace STD is used in C++ to avoid repetitive use of STD within the code. By simply adding namespace STD at the beginning of your code, you save yourself the trouble of having to put it before every cin, cout, and etc. So right here you can see my images. After I put include IOStream, I put using namespace std, and then in the main function I just put cout, and then hello, my name, and then the end line. And on the other side, I did not use namespace std at the top. I did not put using namespace std. So in the main function, for before cout, I had to put std and then colon and colon, and then before the end line, I have to do the same as well, std colon colon. And then if I had put more couts and cins and etc., I would have to continue putting the std in the code because I did not use the using namespace std in the beginning of the program. Next, I will talk about cin and cout. Cin is used to receive input from the user via keyboard or disk. It passes input through the input stream to the program, and you must include IOStream library to utilize it. Cout is very similar to cin. There's a couple of differences. It's used to output data to the computer instead of input. You output data to the computer monitor or local disk. It passes data through also a stream, but it says the output stream. And you, just like cin, you must include the IOStream header file to utilize it. There's also insertion and extraction operators. The extraction operator is used to receive input from the user, and the insertion operator is used to display data to the monitor. Those are the ones you use when you cin or cout. Here's an example of the extraction operator. You can remember the extraction is for cin, so I put cin, two extraction operators, and an age. An insertion operator, cout, an insertion operator, and age. So I'm inserting to display on the screen. So when I cout, and when I cin, I'm extracting from the outside to the program. Arithmetic operator. So for arithmetic operators, there's addition operator, which adds together two values. An example uses x plus y. And there's subtraction operator, which subtracts one value from another. Example being x minus y. There's a multiplication operator, multiplies two values. Example being x times y. And the division operator divides one value by another, x divided by y. Now, these are all common operators in basic mathematics. However, in C++, there is another one called the modulus operator. It returns the remainder of division. So you put x, percent sign, which stands for modulus y. So x modulus y. Let's say 8 modulus 4. The 8 divided by 4 equals 2, right? There's no remainder. So modulus would be 0 because there's no remainder. And had it been 9 modulus 2, the answer would be 1 because there'd be a remainder of 1. So here's an example of me using each of these operators in a program. X plus y, x minus y, x divided by y, and x modulus y. Next, I will talk about relational operator. There's a few types of relational operators. There's the one with the two equal signs, which means equals to. So when I put two equal signs, like I previously said, that means that is the actual value of it is whatever you give it. So let's say I say age equal sign 22. The actual value is 22. And when you put an exclamation point in front of the equal sign, that means not equal to. And then these next ones, these are common ones that you see in basic mathematics. That first sign looks like a mouth eating. It's a less than symbol. And then the next one is the facing the opposite way, which is a greater than. And then also, easy to understand that you put the same operator with the equal signs less than or equal to, and then vice versa, greater than or equal to. And then here's me using them in a program. The x equals to y. So whatever x is, say x is 22, y is 22 as well. Or here it says, okay, so I initialized x as 5 and made y equals 3. But after I would do that, x equals y, that means the y would be 5 as well. And then x does not equal y, and so on. Okay, now I will talk about logical operators. There's three types of logical operators. These are the Boolean operators, as you could say. There's the AND operator, which is using two AND symbols. And for this to be, if you want the statement to be true and you're using an AND, both operands must be true for the statement to be true. On the other hand, the next one, there's two lines, that is OR operator. Only one operand or the other must be true. And the next one is for the third one, it's an exclamation point. That's a not symbol. And if the condition is true, then the operator makes it false. Here's an example for each of them. X equals 5 and y equals 3. So if x and y are greater than 2, see out yes. And the next one is the same thing, but except it says if x or y is greater than 2, see out yes. And then if not x or not y is greater than 2, see out yes. So you can see the different ways you can use them. Conditional statements. If and else statements. So the if statement is a block of code that will execute if and only if the statement is true. And then the else if is used if the if statement is false, this block of code will execute if and only if the statement is true. And then there's the else, which is a block of code that's executed when if statement is false. So when you're running through the code, first it checks the if, and if the if does not meet the requirements, is false, then it goes down to the next one, checks the else if, and if the else if still does not meet the requirements, then it goes to the else. So no matter what, they'll run the else, since it did not meet the requirements for the if for the else if. So right here we have pretty much the same program as the other ones I previously showed, just a bit different. Right here, the first one, if x is greater than 2, see out yes. And if it's not, then if it checks it and if it's not true, then it'll just do the else, we'll see out no. And the other side, I put the same thing except I added an else if, so I gave another option. So it checks the if, and if it's true, it'll see out the yes. And it'll check the else. If it's false, then it'll check the else if, and it'll see out maybe. And if that one is false too, then it'll just see out the no else statement. Okay, loop statements. There's three major types of loop statements: is the while, the do while, and the for. The while loop is a block of code that will continuously execute while a statement is true. And the do while is very similar, however, the difference is it's always going to execute at least once, whether it meets the requirements or not. It should execute at least once, and then continue. It'll do the same as the while after that. And the for loop initializes a variable within the statement, increments or decrements variable each time statement executes, and it'll execute repeatedly while statement is true. So again, here are some examples. The first one I used the while. So while x is less than 10, greater than 10, it will increment the x. So every time the statement is true, x will go up by 1. And then the next one, I did a do while. So in the do while, first it's gonna increment first. So before anything, before it checks the program, before it checks if it meets the requirements, it's an increment first. So int x equals 5, x will be equals 6, and then it'll check the statement. And then the for, as I said right now, you initialize a variable inside it. So int I equals 0, and I put while I is less than 8, I plus plus, and then cout I. So every time that it's less than 8, it's going to increment by 1, and then I put for it to display it. So each time it's going to starts off as 0, it's going to increment, so it's going to display 1, 2, 3, 4, 5, 6, 7, and so on. It's going to display them until after it meets the requirement, then it will stop running. Break and continue statements. A break statement can be used to exit a loop, even if condition has not been met. And a continue is used to skip to the next iteration of a statement. Here are the examples of these. I use for loops in each of them, the same one, except I put in the first one, if I equals 6, break. So once it won't get through the whole loop, once it gets to 6, it's going to exit the loop, and then it would continue with whatever code is next, but since I didn't put any other code, the program will just end. And then the other side, I put if I equals 6, continue. So when you put continue, it'll skip the iteration it's at and it'll jump to the next iteration. Now I will be talking about arrays. An array is a series of elements of the same type placed in a sequential memory location and are referenced by adding an index to each element of the identifier. An array is similar to a basic variable because it can also contain integer or double precision values, and it must also be initialized. The first index in an array is always 0, so if an array has 5 elements, the indices is 0 to 4. And here's an example of an array. I made it an int, I named it A, and I initialized it with 5 elements. And then the 5 elements I included are 2, 4, 6, 8, and 10. And then so there's 5 indices, but it's really 0 through 4 because 0 counts as 1. So 0, 1, 2, 3, and 4. Now I will discuss functions. Function is a group of statements that is given a name and which can be called from some point of the program. A function is very useful when you need to run a block of code on a few occasions throughout the program. Instead of repeatedly typing the same code, you can create it as a function and simply call it every time it is needed. A function can either be a value returning or a void function which returns no values. And here's 2 examples, one of a value returning function and one of a void function. In the value returning function, I used int. You have to give it a data type. So if I used int, that means I wanted to return an integer value as well. And on the other side, I made a program that was a void function. In the void, I didn't have to put any. The difference too between these two is the void does not need parameters, so I left the void empty. And within the void function, I just put cout, hello, my name. And then when I called it, Also, when you call it, you don't need parameters either. You just call the function, and it should do whatever you coded it to do. But the other one, as you can see, when I called it, I had to add parameters, or else it would not run. And a function prototype. A function prototype is a declaration of a function that tells the program about the type of value returned by the function, as well as the type and number of arguments that are included in the function. The function prototype is written just like the function definition, but without the code that is located in the body of the function. So right here above main, you can see I created a function prototype. It's double a double and int double and enter the parameters. But you see I didn't give any parameters, I just put the data type. And you must have a prototype for your function to be able to run. And it must be above the main function, or like outside the main function. Header files. Header files are files and libraries created outside of the main function that are run at the initialization of the program. They can include libraries and files containing predefined as well as user-defined functions. A commonly used header file is IOStream. So you can see right here I put include IOStream and include algorithm. IOStream, that one's used most often. It's used for when you want to input and output data using cin and cout. If you do not include it, you will not be able to use those. Your program will get errors and it won't be able to run. It won't be able to compile and run. And then I also included the algorithm one. That one I was using it when I was making a program for it to do the sorting of data elements. I wanted them to arrange it, so I needed to include this library so I can make that possible. And now we'll talk about strings. Strings are objects that hold a sequence of character elements. There are a variety of memory functions that can be used to create a string. So a string is pretty much like a char variable, except the char variable only holds one symbol, and a string can hold a whole set of symbols. And you could also make string arrays, which you initialize. Let's say I have a string array of 10. That means I'm setting aside 10 bytes in memory for each symbol of that string array. And it becomes very useful in when you want to, instead of having to see out repeatedly a phrase that you want to use often, you can make a string with the phrase in it. So every time you do that, call that string array, it will display the phrase that you created. There's also other forms of strings you can use. You can use strings for the data types. You can see the size of the string and so on. And there's also discussed now call by value and call by reference. Between calling a function by value and reference is that when called by value, only the value is received, but the function is not altered. However, when the function is called by reference, the value may be changed. In order to call a function by reference, you must include the and symbol in front of the argument in the function call. And you must also include the asterisk in the prototype of the function you wish to make changes to. So if it's a value returning function, then and you want to be able to modify it, you what's it called? You use the and symbol and the asterisk so you can make changes to it. If not, you can. I'm sorry. Yes, if you want to call it by reference, and if you want to call it just by the value, you're just borrowing the value, and it's not changing. So it's kind of like in the reference, you're given permission to make a change, and with the value, you're just borrowing it, and you have to give it back the same as it is. You cannot make changes to it. Here's a example of how you would use for it to call by reference. You see on the prototype I used an asterisk, and in the main function when I called it I used a and symbol. I was supposed to use double and symbol. That was a mistake right there, but I used those two for me to be able to make a change to the value. If I had not used that, I would not be able to make a change to the value. I would be able to just use its current value, borrow it, and give it back the same. Now I'll be talking about data structures, particularly struct. Struct is a data structure type that contains various data elements grouped together under one name. The data elements within the struct are known as members. So using struct is something that is very common in real world situations. Like you use this, like say for instance a bank uses struct, like say for their app or something for a user, or ATM. It's like there's different types of accesses for each user. Okay, so right here right now, this is just an example of a struct I created. This is pretty much how you use it. I initialized int variables width and height, and I gave them 10 and 5 as their values. When I see it out, I multiplied them and it gave me 50. So anyway, as I was saying, sorting. Elements can be done in C++ by including a library called algorithm, which I previously discussed. Sorting is commonly used to arrange values either increasing or decreasing order. Below is an example of utilizing sorting in C++ code. So I made a for loop and a array to give me each of these elements, each of these values, 10 values, and they are 0 through 9, but I mixed them up when I initialized them. And then using the sort and mathematical calculations and code, I was able to use the C++ program to arrange them from lowest to highest. I could have also done from highest to lowest. As you can see on the right side where I ran the program, they were mixed up 1, 5, 8, 9, 6, 7, 3, 4, 2, 0. And after the sorting, they were in order of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's how you use sorting in C++. Classes and objects. Okay, so going back to what I was saying about using data structures like struct, this is where you use real life situations where you use classes and objects. This is a user-defined data type that can hold data members as well as member functions. When a class is declared, it is empty. When you declare objects within the class, memory is allocated. The data is accessed via access specifiers. So a class, like I said, it's a data type that can hold data members. So in the ATMs, they use classes, and each class has members, but only certain members can access information depending on their access specifiers. So let me explain the next slide so you can get a better understanding of what I'm trying to say. Specifier is used to control the accessibility of the class member. The three types of specifiers are public, private, and protected. The public specifier can be accessed anywhere in the program and can even be accessed by other classes. The private specifier, on the other hand, cannot be accessed by other classes outside of its own class. Only other member functions of its class can be accessed and can access it. The protected specifier is similar to the private specifier, with the only difference being that the protected specifier allows members to be accessed by any subclass of the given class. So in banking situations, they mostly use the private access specifier, meaning that only the user can't not just access the information directly. They can only access it through what they call it, a friend. It's called a friend member. So they must access the friend member, and the friend member plays the middleman to get them the private member. And this is done to protect people's like information, like social securities, etc. Okay, now I will talk about constructors. A constructor holds the same name as the class and may be defined inside or outside of the class. Three types of constructors that exist are default constructors, parameterized constructors, and copy constructors. The default constructor can be called without having to include arguments or by using default parameters. The parameterized constructor have a specific number of parameters to be passed, and that's a typo, as you can see. A copy constructor recreates a duplicate of an existing class. So pretty much the default constructor, and if you do not declare a constructor by default, you're given that one. And its characteristic is you don't have to include an argument. Like you can leave it blank, or you can set a default argument to be used as the parameter. And the parameterized constructor, which is commonly known like in functions, like has to have a set number of parameters. So when the programmer creates the function, they know how many parameters are being used. So it must be this many parameters, 1 or 2 or so on. And then the copy constructor, say for instance you need an example of, say there's 3 types of cars, and all the cars you have the same information. Instead of writing the same code 3 times, you use a copy constructor to recreate that code for each iteration. Inheritance. This is when a class derives properties and characteristics from another class. It is called inheritance. The class that inherits the properties is known as subclass, and the class that the properties are derived from is called the base class or superclass. So when you're deriving properties, the one that's giving away, that's lending out the properties or characteristics, is the base class, and then the one that is receiving them is called the subclass. So that it would be like when we said the constructors, the copy. Let's say that's like what it would be used for. Overloading. In C++, there's a feature called function overloading and operator overloading, and it is used to give 2 functions the same name but different parameters. Overload resolution is a process for selecting the most appropriate overload function or operator. So based on what code you're writing and what it looks like, the computer using the function overloading, operator overloading feature, it can figure out what would be the best one to use the function or the operator based on what is given, the information, and then from there it will run one of those features for you. File I/O. The input and output classes provided by C++ are used to copy, read from, and write to external files. Stream classes that are featured are ifstream, ofstream, and fstream. So ofstream stands for output file stream and is used to write output to another file. So when you include ofstream, you're using it so you can open up a file, and whatever your code is producing, whatever your result is, your output, it records it in that file and saves there. And like that, like the upstream, if stream stands for in file stream and is used to read data from a file. So when you put if stream and there's an existing file by that name you're putting, you can open the file, retrieve information, and use it in your program. And then you can, well, for both of these, actually all three, to properly run your program, to make sure there's no errors and make sure no compiling errors or your data is wrong, you must, when you open the program, you open the file, you use whatever you need. You must also put to close the file. If you not close the file, then you'll get a problem and error. And then there's the fstream, which is fstream is included when you want the capability to do both. So you use fstream, you can go back and forth outputting to a file and receiving from a file. And now binary search. So binary search is used to quickly locate an element within a set of elements. This method is performed by continuously finding the midpoint of the data set until you have found the specific element you are looking for. A C++ program can be created to perform this procedure. So when you're doing binary search, let's say you have a set of numbers, random numbers. There's 10 elements, say 5, 9, 13, 21, all, 10 elements. And you want to find element 23, but you do not want to have too many iterations, too many runs. You use binary search. So let's say they're in order too, right? So you first find the midpoint, and let's say, okay, we're looking for 23, and let's say the midpoint is 18. So we know that 18 is less than 23. So that being the midpoint, anything on the left side of the 18, the 4 elements on the outside, on the left side, those are canceled out because we know it cannot be there. So from there, okay, so we're at 18 and we're looking for 23, and let's say the bigger element is 40. So from there we find the midpoint again, and if 23 is the midpoint, then you're done. We just need 2 iterations. But if it is not the midpoint, then we may need to do another iteration. So we do the same thing from the 18 and the 40. Those are a total of like 5 elements or so. So you find the midpoint from there, and then so on. And that's how you do binary search. Okay, so thank you for listening to my presentation of all the topics I learned throughout the semester, and have a good day.